the enzyme protein by itself, just the protein, is called apoenzyme. If you add to it either a cofactor or a coenzyme, which can also be called prosthetic group, a coenzyme and a prosthetic group are actually synonymous under many conditions. If you add a prosthetic group and or a cofactor to an apoenzyme, you form the holoenzyme, which is the functional enzyme. So this here, apoenzyme on its own, won't work. This here doesn't do anything because it doesn't have any activity. You put the two together. Let's say the prosthetic group is biotin. You add it to an apoenzyme, then you form the holoenzyme that's active. Okay? So enzymes are classified into two types, general types. One as simple, and those are the enzymes that don't require either a cofactor or a coenzyme. So it's just the protein, just the polypeptide, just the protein that makes up that enzyme. So these are, in a way, a little less interesting. The ones that many of the ones that we will cover in this course are going to fall under this category, complex enzymes. And they're categorized as complex because first, they require at least a cofactor and or a coenzyme to be fully active, to form a holoenzyme. So you need the apoenzyme, you need the prosthetic group, you form a holoenzyme. You may need also a metal like zinc or magnesium and so on. The other important thing about these complex enzymes is that they can be made up of many subunits. Catalytic, that means one part of the enzyme is actually involved in catalysis, in changing a substrate to a product. And regulatory subunits. Okay, so you have one part of the enzyme that is involved in catalysis, another part of the enzyme, part of the same complex, that regulates the activity of the catalytic subunit.